Hello, 8th graders. We're going to look at variables in your experiment. This is ELR 1.2, which says that your job is to identify the independent, dependent, and constant variables in an investigation. This is something that I know that you've seen before, at least since 6th grade science, and so for you this might be a little bit of a review, but it's a really important first step in designing any good experiment. So the reason why we care about these types of variables and giving them names and pointing them out in experiment is so that scientists can have a common language, so that you can go to other scientists and say, this is what my IV was, this is what my DV was, and so that you can talk about your experiment and know what those things mean for your experiment. Also, once you know your own variables, it helps you to complete some other steps down the road that you'll see a little bit more about in a minute. So in this video, like I said a second ago, we're going to do IV, DV, and some control variables. So the first thing that I need you to do is go over to your handout that you should have got to go along with this video. If you don't have one, pause this video. They should be in the classroom for you. There are just a couple of things that I'm going to have you fill in as your notes, and the rest of it is going to be practice. Remember, your notes can come with you to the assessments. So the better of a job you do on your notes, the better your assessment should hopefully go. So let's talk about what a variable is in the first place, and then we'll decide and talk about what the three different kinds of variables are. So a variable is something that you can change or will vary. That's pretty broad. So we're talking about anything in an experiment that could change, which is like almost everything in an experiment. It's almost always something that can be measured. We're going to come back to that idea in just a little bit, but that's what a variable is. So it's a lot of things, and that's one of the reasons why scientists need to define them, so that we know which ones are which. So let's take a second and look at some examples. The first one is the time that it takes to run a kilometer depends on the amount of exercise a person gets. This is an experiment we could do. We could get some people, give them different amounts of exercise, and then clock them for running a kilometer. We could find out, does more exercise mean a better time, and vice versa. So the things that are changing in this experiment are the time that it takes to run a kilometer, that's what we would be measuring in the experiment, and the amount of exercise. The next one is the higher the temperature of water, the faster an egg will cook. This sounds like a really boring experiment, but it's something we could do. The things that are changing here are the temperature of the water, and this one is referring to time, the faster an egg will cook. Faster is kind of a deceiving word. It's not like faster like running a race, but it's amount of time. So those are our two variables. One thing that I want to point out to you, and is a really common mistake in this unit, is notice how descriptive I'm being with each one of my answers. I'm not just saying time. That doesn't tell me much. I have to say time to run a kilometer. The next one, I'm not just saying exercise. I'm saying the amount of exercise. You need to be specific with the thing that you're talking about. I want you to pause this video and try numbers 3 through 6 on your own. If you're still watching, you've finished 3 through 6, let's check your answers. So here's what I have for each one of my answers. You can pause this video and double check. If there are any one of these that you're like, wait a second, that doesn't sound right, that's your cue to raise your hand and ask for help from me in the classroom. You'll notice that number 5 has 3 things that are changing in it. So if you need to pause this video and ask for help, now would be the time to do that. Otherwise, let's go and talk about how to break these variables up. So variables come in different kinds and different types. So the first one, of course, is the independent variable. And that's the thing that you are testing, or the thing that you decide to change. You have to ask yourself, what did the scientist change on purpose? I had a teacher way back when I was in middle school that taught me a thing that I still remember in my brain. And they said, independent variable starts with the letter I. Well, that helps me remember, and now it helps me remember too. And he said, the reason why it helps me remember is because I changed the independent variable. So whatever the thing that you have control over in the experiment, that's the IV. So let's go back to a couple of these examples. The first one is, if temperature increases, then water will evaporate faster. Well, the two variables are the temperature and the rate that the water evaporates. You have to ask yourself, which one of those things do I have more control over? Well, I can't really control how much water evaporates, but I can control the temperature. So that would be my independent variable, or the thing that I'm changing on purpose. The next one, Mr. Nelson notices that Zeb drinks juice, or when he drinks juice, he's in a better mood than when he drinks just water. The two things that are changing here are when Zeb drinks juice and his mood. I can't really control Zeb's mood, but I can control when he drinks juice, or what Zeb drinks. That's our independent variable. Again, I need you to pause this video and try numbers 9 through 12 on your own. If you are still watching, it means that you have finished 9 through 12. Let's check your answers to those. Again, if you are looking at these answers and you are thinking that maybe I made a mistake, or you're not sure where that answer came from, or you're just a little confused, the responsible student choice is to raise your hand, pause this video, and ask for a little bit of help. Otherwise, we're going to go on to the next one. The next variable is, of course, the dependent variable. This is the variable that changes as a result. So the IV is the thing that changes the dV. It's the one we're going to measure. So in this experiment, the first one, if temperature increases, then the rate of evaporation increases. Another really boring experiment. Looks like I'm going to watch water evaporate. Well, the thing I can control in this one is the temperature. That means that the thing I'm measuring, or the dependent variable, is the rate that the water evaporates. In number 14, the closer a planet is to the sun, the warmer its average temperature. This one's a little tricky because I can't actually control either of those. So in this type of experiment, you have to ask yourself, which thing is affecting the other thing? So in this experiment, we have how close a planet is to the sun, and we have its temperature. Well, does the temperature affect where the planet is? Or does where the planet is affect the temperature? Hopefully, to you, the right answer kind of pops out. How close the sun is affects the temperature. The IV makes the dV change, not the other way around. Pause this video if you need to record these things. Otherwise, I need you to go to numbers 15 through 17 on your own. Please pause the video and take care of those now. If you're still watching, you have finished 15 through 17. Let's check your answers there. Here's what I have. Again, pause this video if any of these looks funny to you and you need a little bit more help on these ones. Otherwise, let's go to the last one. For my last type of variable, I want to actually show you a really bad experiment. So I'm going to run an experiment where I'm designing a new sport, but I don't want to use, I want to use an existing ball. I don't want to make up a brand new ball for my sport, and I want one specifically that will bounce really well. So I've got a bunch of different sporting goods. I'm going to test them. Watch my experiment and see if you can figure out what is wrong with my experiment. Here are the 4 sporting goods that I want to test for my new sport. I have a softball, a tennis ball, a racquetball, and a golf ball. In order to test this, I'm going to start with the golf ball, and I'm going to hold it up. And it looks like it bounced up to 80 centimeters. So I added 80 centimeters to my table. The second one I'm going to test is the racquetball. I'll let it bounce, and it looks like it came up to about 72 centimeters. So I put 72 centimeters for racquetball. The next one that I'm going to test is the softball. I'll do that. Ooh. Came to about 24 centimeters. So there's 24 centimeters for softball. Now that softball was awfully loud, and right now the kindergartners are under this classroom, so I'm going to use a piece of foam because that was too loud. For the last one, for my tennis ball, I'll test that, and it came up to about 41 centimeters. So I added 41 centimeters for tennis ball, and it looks like golf ball is my winner, and softball was the loser. Hopefully you saw that in this flawed experiment, I changed things for each one of the sporting goods that I shouldn't have changed. I put a little foam pad under some of the sporting goods that didn't happen in the other ones. Well, that's going to affect my result. That's what's called a control variable. If I drop the sporting goods on the surface of the floor for one experiment, I should do it for all the experiment. A control variable is something that could change, but definitely shouldn't. That's why we control it. We keep it the same. It's on purpose the same for every experiment. So control, or sometimes called a constant variable, is a variable that might affect the experiment, but we keep it from affecting it. That's called a constant or control variable. In a precise experiment, all the variables are kept constant except for the ones we want to change, the IV. So let's take a look at an example. In this experiment, I want to know, does the amount of protein affect how much weight a puppy will gain? So I want to be able to do this experiment so that only the amount of protein is going to affect how much weight the puppy can gain. And there are a lot of other things that could be affecting the weight of the puppy. I want you to pause this video for just a second and make a list on your paper of all the things you can come up with that would also affect the weight of the puppy if we don't keep it the same. I'm going to give you one to get you started. I want to think about the age of the puppies. Think about this. If I started with some of the puppies were like a year old and the other puppies were just a couple of weeks old, those two different ages of puppies are going to gain weight at different rates no matter how much protein they get, just because they have different ages. So we have to keep the age of the puppy the same. That's a constant variable. Pause this video and see if you can come up with a few more. If you're still watching, you've attempted to come up with some of your own. Here are a few more I came up with. We also need to make sure the amount of exercise stays the same. It wouldn't be fair if some get a whole bunch, some get none. Another one is the other food that they get besides protein. How about the amount of sleep? That could affect how much weight they gain. And then the last one I came up with is the breed of dog. Some breeds gain weight faster than others just because they're different breeds. There is an infinite list of control variables. And I want you to know that there's never going to be like, now you've hit the right number. The point of this is to be able to get the ones that matter the most. So here's an example of a not so great one. We could control for the color of their food dish. You may have noticed in the picture, they're all eating out of a blue dish. Sure, we can keep that the same. That is a variable we could control. But I don't think that's really probably going to affect how much weight they gain. So while it is technically a control or a constant variable, it's not a very good one because it's probably not going to affect anything.